All right, this video is going to go into how to evaluate logs. It's not very difficult to do, especially if you watched my previous video of how to convert. So let's go ahead and get started. Whenever I see evaluate and I see like a log function like this, I kind of imagine it saying equals X, because what's going to happen is you're going to do the convert and you're just going to go, okay, well, 3 to the X equals 81. And now it's just an exponential problem to solve. So like you would change 81 to be 3 to the 4th, and then you could just be like, okay, X equals 4. And so like you don't actually write X equals 4, you just say, okay, well, that's 4. So let's look at a couple more. So like this next one, I would be like, okay, 7 to the something equals 49. You can change 49 to be 7 squared, or you can just, sorry, I kind of got distracted there. You could change 49 to be 7 squared, or you could just look at it and know X equals 2. And so this one, I would just say, okay, this has a value of 2. So that's how I do those basic ones. Now, 36, same thing. So you're like, okay, well, 5 to the something equals 1 over 125. Then you change 125 to be 5 cubed, but you need base 5, so you got to bring it to the top, and when that happens, it makes it a negative exponent. So this one would be -3. Okay, now when there's not a number there, like on 37, it's a 10 for the base. So this one's really like 10 to the X equals 10,000. And with the tens, you can just count the zeros. So like this one, 10,000 has 4 zeros. Well, that's 10 to the 4. So therefore, X equals 4. So this one, when you evaluate it, the answer would be 4. Now the decimal ones are a little trickier. So follow the same pattern. So it's 10 to the X equals 0.000001. All right, now me personally, these are difficult for me. I don't know why. It's just like something blocks my brain there in terms of understanding it. So here's what I do. I think to myself, okay, 0.1 is 1/10, aka 10 to the -1. 0.01 is 10 to the -2. And I do this so on and so forth until I get to what I'm looking for. So this one, this is going to be 10 to the -6. So I hope that made sense. This is how I have to think about it in my head. Maybe there's an easier way. I'm not sure, but that's how I do it. Okay, now look at 39. When you see ln, it's really like it says log base e of e cubed. So you're going, okay, well, e to the something is e to the 3, and therefore it's just X equals 3. So this one, when you evaluate it, you would get an answer of 3. All right, now what they're going to do is they're going to throw numbers in front, like 40. So you're looking at 3. Remember, ln is just log base e. Almost every time I see the word ln, I rewrite it as log base e. So what you're going to do is you're going to evaluate this part first. E to the X equals e to the -4. So therefore, X equals -4. So this whole red part here is just -4. And then you take care of the 3 that was sitting out front. So this one, when you evaluate it, you get -12. I hope that made sense. So like on the next one, you would do, remember this is log base e. So you would do this blue part first. So you'd go e to the X equals e to the 18, therefore X equals 18. So this blue part is 18. And so really what you have here is you have 18 and then minus that 6, which makes it 12 when you evaluate it. So that's how you're going to do all of these. I guess I should do 43. It's jumping out at me as kind of like a difficult problem. All right, you've got log 2/3 of 9/4 minus 6 log base e of e to the 1/3. Okay, let's focus on this red part first. This is 2/3 to the something makes 9/4. All right, if you notice, the 2 and the 3 switch sides and they get squared. So what that means is this 9/4, this is the same thing as 2/3 to the -2. So when you evaluate this first red section, you get -2 because it's like this. So the red section is -2. Now let's do this green section. Focus on just this part first. So you're going like e to the something equals e to the 1/3. Therefore, it's 1/3. But you still have that 6 that's sitting in front there. So when you multiply this, 6 times 1/3 is 2. So really what you have is -2 minus 2, and it's minus because this guy in the middle, this minus sign in the middle. So when you evaluate this whole thing, you get -4. That's kind of a tricky problem. Okay, now some of the things that they can do with this is like the next one, 44. We have log base e of e to the -2, all raised to the power of 5. So what you got to do is you have to do just this red part first. And this red part's like, okay, e to the x equals e to the -2. Therefore, it's x equals -2. When you evaluate the red part, you get -2. But you're not done because they raised it to the 5th power. So really what you have to do is -2 to the power of 5, which is -32. Okay. We'll just work through a couple of these. Like this one, you would do this log part first, which gives you 1. So really you have -4 times 1. And you do this bottom part, do the ln e, which is 1. So you have like 5 times 1. So this one's just -4 over 5. Okay, 48 is one that I would recommend you know as well. This is log base 2 of 8 root 2. So you're like, okay, well, 2 to the x equals 8 root 2. You have to realize that 8 is 2 cubed, and root 2 is 2 to the 1/2. So when you combine these, when you combine both of these, you get 2 to the 3 plus 1/2. 3 plus 1/2. Well, 3 plus 1/2, it's really like 6 halves plus 1/2. It's 7 halves. So when it's all said and done, you had 2 to the x equals 2 to the 7 halves. So when you evaluate it, it's 7 halves. It's kind of a tricky one when they throw some roots in there like that. So like 50 is 15 to the x equals root 15. Well, root 15 is 15 to the 1/2. So when you evaluate this one, you get 1/2. Okay. If they give you something like 49, that's kind of another tricky one. You're going to want to do the inside first and work your way out. So this right here, 81, is 3 to the 4th. This right here is 3 to the 4th. So, and then when you cube root that, really it's like 3 to the 4/3, like that. And 27 is 3 cubed. And then it gets raised to this other power of 5. It makes 3 to the 15. So the fact that these are multiplying means you're going to have to add them. So 15 is the same thing as 45 over 3. So when you combine these, you get 49 over 3. That's just this inside part. We haven't even messed with the log yet. Here's the log part. That's going to be here. And so this is what the same problem, just kind of rearranged. And so you're like, okay, well, 3 to the x equals 3 to the 49 over 3. So it's obviously 49 over 3 when you finish evaluating it. That's a tricky problem. All right, number 54, they're going to throw some trig at you. So you need to evaluate this cosine pi first. Cosine of pi is -1. So really this is like ln of -1, or really it's like log base e of -1. Well, this is a huge red flag. You can't do log or ln of a negative number. It does not exist. So this answer would either be D in E for does not exist, or you could probably get away with the no solution as your answer. So, okay, let's keep moving. All right, now look at 53. You have to evaluate tan pi over 4. Tan pi over 4 is 1. So really you have ln of 1, which is log base E of 1. So when you go to evaluate it, you're like, okay, well, e to the something makes 1. The only exponent that could possibly be here would be 0, because anything to the 0 is a value of 1. So therefore, this one, when you evaluate it, is 0. Okay, and now we'll look at one of these last two. It doesn't really matter. They're basically the same problem. You're going to have to evaluate tan pi over 6. Tan of pi over 6 is 1 over the square root of 3. Okay? And so basically, that's 1 over 3 to the 1/2. And so basically, that's 3 to the -1/2. That's just this blue part. We haven't done the red part or the green part yet. So let's do the red next. You're looking at log base 3 of this, right? So 3 to the something makes 3 to the -1/2. So that's going to be -1/2. Now you have the times by 2 at the start. That's how you get your final answer of -1. So you're still just using the snail method to convert it. And once you do that, it's just an exponential problem. They're not that bad. Hope this video helped.